Okay, so here's your video tutorial for the day. The big idea, the focus of this lesson is to kind of take our work with radicals from yesterday and kind of how to simplify. But in that lesson, we were really primarily multiplying and dividing, whereas in this lesson, it really brings in the operations of addition and subtraction. However, the focus still remains, how can we simplify these expressions so that we can perform these operations? And a lot of the problems really focus on finding the perimeter and area of different shapes, primarily triangles, when we know the dimensions, but the dimensions are given kind of with radicals included in their value. So this first problem, I'm just going to walk through this first example, is directly from your lesson, and it really is just kind of a matter of simplifying. So when I see this, square root of 32, I know that there's some factors such as 16 and 2 that I can include. So I could rewrite this as the square root of 16 times the square root of 2. And again, this is just kind of review, but that just breaks down. Since 16 is a perfect square, the square root of 16 is 4. So I'd be left with 4 times the square root of 2. So that's, again, just kind of to recap, one of the kind of big ideas from yesterday is how can we kind of simplify this so that we have perfect squares that we can then perform the radical and then leave this kind of as a prime, simplified version will be multiplied by a prime with a radical, or a square root in this case. So then in this case, if I'm thinking about, this is really exercise 5 from your lesson, this one that I'm just putting a star next to right now. So it kind of asks, what if these were dimensions and I wanted to find the perimeter? How could I add these, or how could I combine these sides to find the perimeter of a figure if this was like side 1, 2, and 3 of a triangle? But I can't necessarily add them as they are, but I can, however, simplify. So this guy, I think, is as simple as it can get because it already is being multiplied by a radical with a prime number 3. However, 12 I could rewrite as 4, the square root of 4 being multiplied by the square root of 3. And I know that the square root of 4 is 2, so I'm just going to rewrite this. Instead of having it as the square root of 4, I'm just going to rewrite that as 2 times the square root of 3. So that's the way I could factor that square root of 12. I could do that same thing with the square root of 75, because I know 25, and then again times the square root of 3. That would also be equivalent to the square root of 75, but very similar to what I did previously, the square root of 25 is 5. So I'm just going to rewrite that as 5. But now you'll see, just like you kind of hopefully noticed in the example above in exercise 4, that when I have this kind of, you can almost think of it as like the same base in terms of exponents, and when you have that, you can really just add the leading terms. So 4 and 2 is 6 and 5 is 11, so this would be 11 times the square root of 3. And I just arrived at that kind of by simplifying all of these to have a radical 3. Okay? So another example that we could do, let me jump over a little bit. And this, a little bit further on in your lesson, it asks if you can use the distributive property. So it says, can we use the distributive property to work with this and simplify it? And I think we can. So notice that right now this is really, the radical is over 2, and so that's prime, like we can't do anything about that, but that's not the case with 8. So I can start by kind of trying to distribute that 8 out. So I could rewrite it as 2 and multiply that by the square root of 4, and that could be then times by just the square root of 2, because again, square root of 4 times square root of 2 is equivalent to the square root of 8, and that 2 is still leading term right there, so it's really like I distributed it out if you want to think of it like that. So with that being said, and I'm just going to kind of keep this simple, so with that being said, we now still have 19 in the square root of 2. I'm just bringing that down, because that's ultimately what I'm adding. But now I do know that the square root of 4 is 2, so if I just bring this down, that really is 2 times 2. And we're still adding the 19 to the square root of 2 to that. And then we still have this square root of 2 as well. So when I combine all this, we really just have 2 times 2 is 4. So we have 4 times the square root of 2 plus 19 times the square root of 2. So when we combine that last step, we really get the 19 and 4 combining to be 23 times the square root of 2. So that's just kind of a quick example of using the distributive property to kind of factor this base of 8 that had the radical over it, or the square root symbol. Okay? So hopefully that helps. Again, that discussion form is there. I know there was a couple questions that got posted yesterday that I'm going to respond to today. But hopefully you guys are doing okay and be feeling successful. All right, good luck.